Poi ma che come? Quello allora sì.
Check account name now, take the same thing. Tó bá jẹ́ the same thing, máa yọ kúrò. Ibi àdírẹ́sì ẹ̀ wá kó àdírẹ́sì ẹ̀ jáde.
You know the meaning of shiri. Shiri. You know the meaning of shiri. Open your eyes. Shiri. That's the meaning. See, hold on now. In Yoruba, shidi. Shidi means open your eyes.
Hello, good evening. I hope you're all doing great. Welcome to today's class. We'll pick up from where we left yesterday. So yesterday we started looking at functions and formulas in Excel. So today now we'll start applying some of those formulas to perform data cleaning. So in the first class, I demonstrated the process that is typically followed in data analysis. And the very first step after gathering your data is to clean the data and make sure it's ready for analysis. So beginning today, we'll start looking at the process of cleaning data, the various aspects of cleaning data, etc. Before that, we'll maybe start with how we import data into Excel. So allow me to share my screen. Cool. And I hope you can hear me clearly. I didn't confirm that before beginning. Hmm. Perfect. So anytime you are working on a given data set and you want to use Excel to analyze it, the very first step is to import that data cell into our Excel workbook or worksheet. So Excel provides several methods for importing data, including text files, databases, web pages, other Excel books, etc. As I had mentioned yesterday, some processes differ between Google Sheet and Microsoft Excel. For instance, when importing data in Google Sheets, we use the File tab, but in Excel, I think it's the Data tab. But someone using Microsoft Excel will confirm on that. So we first create a, we need to do that. Let me create from here. Let me create a new sheet so that I briefly demonstrate the process of importing data. Assuming we are using the Google Sheets, like in my case, we import data from the File tab. If using Excel, I believe it's in the Data tab. I'm not very sure, but I think it's in the Data tab. But someone with Excel will confirm that. In my case, because I'm using Google Sheets, all I need to do is to click on the File tab, and then the third option is Import. On clicking that, they'll pop up a dialog box where now you can search for the location where your data set is stored. Let's say, for instance, I want to import a CSV database. Because these are the various data sets within my system. Most of them are Excel sheets. In our case, let's import our CSV file. This will be perfect. So I'll select it and click Insert. Then it will prompt me to enter the import location, either to replace the spreadsheet or to create new. In this case, I wanted to replace because actually it's empty. Then separator type, how you want your data to be separated. I want it to detect automatically. Although we know CSV, which is in full is comma separated values, they are separated by commas. I'll show you how it looks like in its raw form. So let me give the Excel the freedom to detect automatically the separator type within my data. So with that, I can import the data. Oops. Let it load. So Excel will automatically establish or discover that the various entries or columns are separated by commas in a CSV file. Let me see if I can trace that file, show you how a CSV document looks like. For those maybe who have never interacted with a CSV file, search .csv. This is the exact document I just imported. So let me see if I can open it with an IDE. Perfect. If I were to open that dataset with VS Code IDE, this is how it looks like. You can see the various columns or entries are separated using commas. From 1995, comma, avatar. This means these are different columns, each separated by commas. That's why it's referred to as comma separated values. So this is how that data set looks like. And upon importing it, this is how it looks like now in an Excel sheet or workbook. That's basically how we import data into Excel. The same process we use to import other file formats. Perfect. With that, I can proceed. Now we can start looking at the process of cleaning the data. And we'll start looking at outliers. So what do I mean by data cleaning? In the context of data analysis, it refers to the process you follow to detect, to correct, or remove inaccurate, incomplete, or irrelevant data within a data set. So this step is very critical when preparing your data for analysis because it ensures data accuracy, consistent, and it's also reliable for analysis. So basically, data cleaning aims to improve the quality of data, making it suitable for further analysis and decision making. So what are some of the key aspects of data cleaning process? One, data cleaning ensures the data is consistent across the entire database, which includes standardizing formats, e.g. dates, currency, etc. We'll see more on standardization when we'll be looking at Power BI. We'll be looking at data modeling. We'll look more into how we standardize various formats. Also, data cleaning ensures the data is correct and free from errors, which include typographical errors, inconsistencies in naming conventions, and maybe inaccuracies from data entry. Also, data cleaning addresses missing data points. Sometimes we might be working with a data set with missing values. So you need to clean it and sort out that. We look at how we deal with missing values later, maybe within this week or early next week. Also, data cleaning ensures that data conforms to predefined rules and constraints, which includes checking for outliers, which may indicate errors or anomalies in the data. So we'll start with looking at how we deal with outliers when cleaning the data. It's a concept that we came across earlier last week, and I believe all of us by now knows what an outlier is and what it can do to data. So just for repetition, outliers are data points that are significantly differ from the rest of the other observations or from the rest of observations within a data set. So these observations are unusual, usually because they fall far outside the typical range of the other values within that data set. As we seen earlier, or as we saw earlier, outliers can have a significant impact on statistical analysis and machine learning models. So they can easily skew the results of data analysis, affecting the measures of central tendency and measures of dispersion. So although outliers are very common in dataset, they can be avoided in some situations, especially when they are as a result of typos or typing errors or entry errors. So therefore, understanding what causes outliers is essential for anyone working with data to ensure that they put measures to avoid outliers in the dataset when necessary. So what are some of the common causes of outliers in a dataset? For one, it's as a result of errors in measurement or data entry. They can also arise from errors in the sampling process. So if the sample is not a representative of the population, it may contain outliers that might not reflect the true characteristic of the population. For instance, maybe you are collecting data about salary scales for teachers, and by mistake you give the questionnaire to someone in a different field, maybe a software engineer. Their salaries might differ as significantly. So in that case, it will be as a result of an error during the sampling process, meaning that you included someone in the sample who was not supposed to be in that sample. Also, outliers can be as a result of extreme or rare events that are not representative of the typical behavior of the data. For instance, a sudden spike in sales due to one-time promotion could result in outliers in a sales data set. Also, outliers can be introduced during data processing and data transformation. An example, errors in data normalization or scaling could result to outliers. So it's very essential when doing data normalization or standardization to be keen not to introduce outliers in the data. Also, in other cases, these outliers can occur naturally due to the inherent variability in the data. For example, a dataset containing employee salaries for a certain age group, some few employees might be earning substantially high amounts compared to the rest of the group. Also, in some cases, outliers might be introduced into the data for various reasons, such as if you want to test the robustness of a statistical model or identifying anomalies within the data. Cool. So there are several methods you can use to identify outliers in a data set. One, we can use visualizations, particularly scatter plot is widely used for that purpose. We can also use some tests such as the Z-score test. And we can also use interquartile range, IQR. We look at each one of them. So the first method you can use, especially when you have a small data set, is use of visualization, visual charts or visualizations. In this case, scatter plot is very widely used in that case, but it doesn't mean it's the only chart you can use. The choice is yours, but scatter plot is works better when identifying anomalies or outliers in a data set. So let's assume we are working with a simpler data set. Yeah, let's assuming we are working with this data set. It has salaries of some employees. It has 4 columns with the employee ID, their name, employment type, and their salary. So we want to check if the salary data or salary inputs have some outliers. So to do that, we can use a chart. So because I want to check for anomalies or outliers within the salary column, which is column D, I need to plot it against another column. I can choose maybe column C will not be cannot be used for that purpose. I need a column that is a representation of each employee. So the best column to use is column A. So I'll plot column A against column D. So I need to select the two columns. Then head to Insert tab. The Insert, there are charts. The process might be a little bit different when using Microsoft Excel. So I want to insert a chart. So automatically it has inserted a bar chart. But as you can see already, the bar chart can help you identify which data points might be extreme. In this case, we can already visualize the employee with the employee ID 1003. Their salary is so large compared to the rest. Also with employee ID 1010. Let me change that to a scatter plot. The histogram. Scatter. As you can see, all the data points are in this range. However, there are 3 data points that seems to be outside the range. This data point, maybe I can give them a different fill color. Need to select these. You can give selecting to select only one. Let's return them to blue. I only want to change the color of the outliers. Be very hard to click on that. But anyway, basically that's how you can use a scatter plot to identify values that might be outliers within a data set. It's very simple and straightforward, but you can only use it with small data sets because if the data set have dozens of entries, it cannot be possible to use a chart. Cool, you can proceed. That was very simple and straightforward. These are just explanations of how to achieve what you have just done. So basically you use your judgment and statistical knowledge to determine if a point is truly an outlier or if it represents a valid data point. So if you have more variables to analyze, repeat the process by creating scatter plots for different pairs of variables to detect outliers in each case. In our case, we had a very small data set, so we could only check for outliers within the salary data. So once you have identified the outliers, you can record them in your dataset or in a separate document for further analysis or treatment. You can also use other charts to achieve that. So let's look at other more advanced ways of checking or detecting outliers in a data set. Another key technique we can use is the IQR or interquartile range. So I have illustrated the process. You can go over it. So allow me to head direct to the data set for a demonstration. First, remove this chart, we no longer need it. We'll still work with the same data. I want us to use a different technique, which is IQR, to detect outliers. So to achieve that, it's a quite a small process. We first need to calculate or to identify the lower quartile and the upper quartile. Then we'll use that to calculate the interquartile range, which is the difference between the upper quartile and the lower quartile. Then we'll use the IQR or the interquartile range to calculate the upper range and lower range, or other words, the upper bound and the lower bound. And any value below the lower range or above the upper range will be considered an outlier. So we'll use a very simple process because I want to check outliers for column D, the salaries. So to get the lower quartile and upper quartile, we need to sort that column or the data set in an ascending order with the reference of that column. So need to sort these from A to Z. As you can see, it has also sorted our titles. I didn't want that. So you can do that. To avoid that, I need to first create a filter. Then, yeah, now I can sort it from the filter. Yeah, now it's sorted from the lowest salary all the way to the largest. Now it's sorted in an ascending order. So with that, I can go ahead and before then, because I need to identify the lower quartile and the upper quartile. In other words, the lower quartile is the median of the lower median. I'll demonstrate that in a few. In a few. Then the upper quartile is like the median of the upper median range. What do I mean with that? For easier demonstration, let me create another column and name it custom ID. And I want to give each employee a custom ID running from 1 all the way to the last employee. I can populate the other columns. So this is a very small data set, so I don't need to calculate the median. I can just spot the median with bare eyes. So in this case, the median is is the value 10, the average of value 10 and value 11, because we have 20 entries. So this will be the midpoint. So I need to divide the data set into 2 equal halves. So the first half we run from custom ID 1 all the way to 10. The second half we run from 11 all the way to 20. Now I need to identify the median of the upper part or the upper range and the lower range. I don't know if that's understandable. And the median of these lower range from custom ID 1 to 10 will form the lower quartile, while the median of the upper range will form the upper quartile. So I need not to obtain the midpoint again or the median. The salary, the median of the salary for the employee with custom ID 1 all the way to 10. So the midpoint again will be at value 5 and 6. You can also calculate the median if you want, but in this case, because I have a very small data set, I can identify it using bare eyes. So I need to get the average of these two salaries to get the lower quartile. So in this case, quartile will be the average of these, so it will be equals to average of these and that. I'll do the same for the upper range from custom ID 10 all the way to custom ID 11 all the way to custom ID 20. The median will be the average of employee number 15 and 16 salaries. So I'll do the same again for the upper quartile. Equals to average with that, we have calculated the lower quartile and the upper quartile. So the next step, as I had explained, is to calculate the IQR or the interquartile range, which is the difference between the upper quartile and the lower quartile. So I can go ahead and calculate the IQR. It will be equals to this minus the lower quartile. This, let me shade it with a different color because I'll use that value. So with that, we have calculated the interquartile range, the IQR. So now you can calculate the upper range and the lower range. And the formula for calculating the upper range will be 1.5 times the IQR plus the upper quartile value. Just call it UQ to represent the upper quartile for simplicity. So you can, it's a custom formula, so it's equals to 1.5 multiplied by the IQR as the upper quartile. We'll do the same for the lower range. Now the formula for calculating the lower range is lower quartile minus the product of 1.5 multiplied by the IQR. IQR. So another custom formula is equals to the lower quartile minus 1.5 multiplied by the IQR. So with that, we have calculated the upper range and the lower range. So any value out of that range above the upper range or below the lower range can be considered an outlier. So with that, we can use conditional formatting. Format this column. You can use conditional formatting to highlight the outliers within this data set in the context of the IQR we have just calculated. So format, condition of formatting. The format rule is it's between, or it's not between. So it'll work, it's not between 41,500 being the lower range and 81,500 being the upper range. Different color. Great. With that, we have identified and highlighted the outliers within the data set. So now we can go ahead and deal with them. We look at how we deal with the outliers shortly. You can either remove them, you can treat them as missing values, you can impute them. There are various methods we look at. So I hope you are able to understand that, but no worries, I have elaborated the process in the slides. So if you didn't understand it fully, you can take it from the slides. Unless there's anyone who needs any clarification. Cool. Another method we can use is the Z-score. This one I haven't included in the slides. Oh, let's work with these. To we'll use as a very simple function in Excel called standardize to calculate the Z scores. In this case, we are working with another very simple dummy data set with test scores for 15 students. So the data set has two columns, the student ID and the corresponding test score. So to calculate the Z score using the standardized function in Excel, we first need to calculate the standard deviation of the population. We need to calculate the mean. Yeah, so I think those are, what else do we need? I think we also need to calculate the range, which is the difference between the maximum value and the minimum value. So first thing I need to do, I need to calculate the standard deviation for the scores. So is equals to STD. It's my reload it. Perfect. So the first thing we need to calculate is the standard deviation. It's equals to STD. We need to calculate the standard deviation of all the scores. We need to do the same to calculate the mean, so it's equals to average. Average. To get the mean value. So the maximum value then the range will be the difference between the maximum value and the minimum value. With that, we can compute Z scores for each and every student. So as I said, we'll use the standardized function in Excel. Which basically takes 3 parameters, the value, mean, and the standard deviation. So the value in this case will be each individual test score for every student. So, and we loop from the student, the first student, then the mean, standard deviation. Since we only need to keep looping through the scores, so the value in this case will keep changing, but the mean and the standard deviation is the single value. So if we put it like this, it might print an error for the subsequent students. Yeah, it won't calculate. So it has already suggested to us we need to add dollar signs. So all you need to do is to add dollar signs. The purpose of adding a dollar sign is to create an absolute reference for that cell, because we want it to reference the cell with standard deviation and the cell with the mean for all the other values. So that's why you have to add the dollar sign between the to enclose the what do you call it, the letter. I don't know how to explain that, but basically you have to add dollar sign before and after the letter for each column. So in this case for F and E, meaning that we want Excel, what we are trying to do is to tell Excel this is an absolute reference. So this will ensure that the formula is when the formula is copied to the other cells, the reference to this cells will not change. But as you can see from the formula, for the B2, we have not added any dollar signs because they will keep changing as we iterate through the student scores. Perfect. Now you have calculated the Z scores. Now, how do you use them to identify anomalies or outliers within the test scores? So normally for large data sets, there are two common ranges that are used, either the absolute 2.5 or absolute 2.68, but doesn't mean that's the only ranges that you can use to identify outliers when using the Z score. Usually it will depend with the sample size of your data, and again, or your data, the size of your data set, and the difference between the extreme values and the other values. So in our case, because we have a small data set, personally I like using one unless it's advised otherwise. I like using absolute one to identify outliers. But again, this is now subjective between or among various or different analysts. So it's upon your judgment and the exact range you want to use. For in this case, let's assume we want to use absolute one as the outlier. Absolute one means you ignore the sign, whether it's negative or positive. So we'll consider any absolute value above one to be an outlier. So to do that, we can still use conditional formatting. I think we can use conditional formatting to achieve that. So I want to check outliers in column B. I'm not sure this will work. Let's try it out. So I want to use conditional formatting. So I want to check all the Z scores and check if the absolute value of the Z score is above one, it will be treated as an outlier. Now I'm assuming I have a very large data set. I cannot use my eyes to check. So perfect. Let's remove the existing and create a new one. Create a new rule. Yeah. So let's use a new rule. So I want to use a custom formula to check if the absolute value of the Z scores is greater than one. So I'll use a custom formula. I want to check if the absolute value, which is represented as ABS in Excel, the absolute value in cell C2, because I want to iterate from cell E2 all the way to all the way to C16. So if that is greater than one, change the color to like that. Done. See, so it has lighted 65 as an outlier. 26 now. It didn't work. Check these. Iterating from it is supposed to iterate from the first cell. Oh, because we have the titles, I need to start with cell C1, if I'm not wrong. Yeah, that works. Cool. Now with that, we can be able to visualize that the student in row number 4, whose text score is 22, it's further away from the other scores, which is too low. It might be an outlier. 96 might be an outlier. 34 might be an outlier. Yeah, so that works. So basically, those are some of the methods you can use to identify outliers in a given data set. I don't know if I confused you. Is anyone with any question before you proceed? Cool. Yeah. So those are some of the methods you can use to identify outliers. But there are other methods you can explore on your own. Whew. So I think with that, we can proceed. So now after we have identified outliers in a data set, how do we deal with them? So there are several methods we can use to deal with outliers, which includes we can remove them from the data set, we can transform them, we can treat them as missing values. So we'll see how we treat missing values later on in the course. So the choice of the method used to deal with the outliers varies and depends on the nature of the data and the goals you have for the analysis. So one method we can use is to remove the outliers, which means deleting the entire entry or row consisting an outlier. But we cannot use this method always, particularly when maybe the data set, the sample size is small, because if maybe you had a sample size of 15 and you remove 4 entries, you are significantly affecting your sample size, and it might give you biased results. Also, in some cases, you might discover the outliers are valid data points. So in that case, you cannot remove them. You can maybe, if you feel they are distorting the results of your analysis, you can transform them maybe to an logarithmic scale or a square root scale. So some instances where removing outliers can be applicable over other approaches include when outliers are clearly due to errors or entry mistakes. For example, if a temperature sensor malfunctioned and recorded extremely high or low temperatures, removing such an outlier will make so much sense. Also, if the outliers have significant impact on the results or conclusions drawn from the data, in that case, removing them will be justified. Also, when the underlying distribution of the data is known or is assumed to be normal. So in that case, you might consider to remove the outliers because they are giving the wrong results. Because if the distribution was assumed or pre-known to be normal, having outliers will skew your results, meaning they will be invalid. So you have to remove the outliers in such a case. Also, when the outliers are suspected to be due to data quality issues, such as maybe when equipment malfunctioned. Also, if the data is used for parametric statistical analysis, like e.g. things like the mean standard deviation, t-test, etc. So also we have some advantages and limitations of removing outliers. For one advantage is removing them can lead to more accurate and reliable results by reducing the influence of extreme values on the statistical analysis. So sometimes the outliers can distort the interpretation of data. So remove them will lead to clearer and more meaningful conclusions. Also, in predictive analysis, outliers can adversely affect the performance of the model. So removing them can improve the model's predictive ability. However, removing the outliers might be disadvantageous in some situations. So removing them may result in loss of potentially valuable information, especially if the outliers are genuine data points that provide insights into the underlying phenomenon. Also, identifying outliers can be subjective, and different analysts may choose to remove different data points, which now will lead to varying results. Also, reducing outliers reduces the sample size, so it's not effective for small data sets. Also, you can deal with outliers by transforming the data. So data transformation generally involves applying a function to the data values to change their distribution or scale. So this can help to make the data more suitable for analysis and to reduce the impact of the outliers. So for an example, in financial data analysis, stock prices may exhibit a skew distribution with extreme values. So in such a case, transforming this data using a logarithmic or square root transformation can help make the distribution more symmetrical and reduce the influence of these outliers. Let's take an example of data set we do use. Let's work with this again. And you can convert the salaries to a logarithmic scale. So it goes to logarithm of to calculate the logarithm of all the salaries to base 10 and plot it again. Now we can plot employee D against the logarithm scale for the salaries. Chart. Let's see how different it looks from when that doesn't make sense. Oh, I know. Let me use a scatter plot instead of a line. As you can see now, the data points are very close to each other. When we transform it to a logarithmic scale, you reduce the influence of the extreme values in your analysis. So now you can use the logarithm values for your analysis instead of using the actual salaries to reduce the effects of the extreme values. Great. So I've just demonstrated the process. You can either convert it to logarithm, square root, reciprocal transformations, etc. Also, if you choose to use transformation as your method of dealing with outliers, it's good to document the transformation and any changes made to the original dataset to ensure transparency and reproducibility, so that even someone else comes and tries to look what you or tries to figure out how you analyze the data, they can use the documentation to see the kind of transformation you have done on the data. Some of the advantages and limitations of data transformation. So for one, transformations like the logarithmic or power transformations, as we have seen, can reduce the impact of outliers, making the data less sensitive to extreme values. Also, data transformation can normalize the distribution of the data, which now makes it easier to apply statistical techniques that assume normality. Also, transforming data can lead to better model performance and doing things like predictive analytics. Some of the disadvantages include transforming data can lead to loss of information, especially if the transformation is not reversible or if important patterns are lost. Also, transformed data may be very challenging to interpret, especially if the transformation is complex and nonlinear. Also, while data transformation can reduce the impact of outliers, it may not completely eliminate their influence, especially if the outliers are extreme. Even if you transform them, they still affect the distribution of your data. I think we can stop at there. We'll finish up tomorrow. I don't want to get you so much tired. I know today's class was a little bit tough, but it's something if you didn't understand the concepts well, you'll go over them on your own. They are very easy to grasp, very easy. But in most cases, when learning a concept the first time, you don't really understand it. It feels so confusing. So, but the more you do it, the easier it gets. I think I'll finish up on the slides tomorrow as I continue what we have to cover tomorrow. I think tomorrow's class won't be so technical. So we'll finish up on the remaining slides tomorrow. I'm also tired. Yeah, I joined the class after finishing my work day, and I usually have a very rough day. But I'm trying my best to teach you guys and to see if we'll make another generation of data analysts who have the capacity to develop to become the next data engineers. So I have seen Vivian have sent the attendance form. Let me organize for the quiz. The dummy dataset, I'll send them to you on via the WhatsApp group. Also, you can use ChatGPT. I usually use ChatGPT to generate dummy datasets. It helps a lot. you can use that. Again, online, there are so many data sets, like the movies data set, the CSV data set I was demonstrating with. I downloaded it from an online platform sometime when I was creating a movie watching application, and I was into software engineering. So you can get these data sets online. You can also use ChatGPT to generate dummy data sets, but I'll send the ones I have used. I think this one and this one. I'll send them to you via WhatsApp. I'll send a link. All you'll need to do, because it will be viewing only, so you'll create a copy and work with it. And actually, I won't even delete what you have done, such that you can follow through. I'll send it with the way it is, with the calculations. So I believe that will help. So let me organize for the quiz. Allow me to drop off the call. I need to start preparing to go home. But kindly ensure you have signed the attendance form and you have attempted the quiz. Once you're done with that, you are free to drop off the call. But before then, kindly hang on a minute. So have a nice evening and see you tomorrow. Nelly, the link is dropping in a few. Hang on a little bit. It's on the way.
Okay, good evening, everyone. Please try and attempt your quiz. The link has been dropped. Also, fill in your attendance. Once you're done with that, then you can leave the meeting. Thank you.